Hello friends, welcome to everyone to our engineering drawing lab. Today I will explain the projection of planes. So first we will know what is plane. A flat sheet or surface has zero or any negligible thickness but has mass is called the plane or lamina. For example, a sheet of paper is a lamina. We see here a plane is a two-dimensional object having length and breadth only, and its thickness is always neglected. A plane has two types of basic shapes. One is the irregular shapes and another one is the regular shapes. Now we will see what's the basic difference between the regular and irregular shapes. In regular shapes, all the sides are in equal, and also all the internal angle between two sides are in equal. In other hands, in irregular shapes, both the sides and internal angle are not in equal. So this is the basic difference. Also here we cannot discuss about the irregular shapes because all of our problems are related to the regular shapes. So there are some basic regular shapes. Any type of polygon such as pentagon, triangle, square, octagon, and also a circular flat plane. So now directly we will go to our problem number 1, which is a regular pentagon of 25 mm sides has one side on the ground. Its plane is inclined at 45 degree to the horizontal plane and perpendicular to the vertical plane. Draw its projections. So before starting, we will take a little practical look at the problem. So this is the vertical plane and this is the horizontal plane. And here is our pentagon. Pentagon is a polygon where the number of sides is 5. 1, 2, 3, 4, 5. And it is resting by one of its sides, not corners. So the resting plane is horizontal plane, HP. Look here, suppose this pentagon is resting by using these sides, and at a time it makes an angle with the HP, just like this. Now look carefully, suppose this pentagon is resting by one of its corner, and then it's make an angle with the HP in this way, but the shape of the top view would changed in both the cases. And notice that in that time it's also make an angle with the VP, but here given that the pentagon is perpendicular to the VP, so we have to draw a line along these sides up to VP, and it makes an angle 90 degree. That means the pentagon will be perpendicular to the VP, which is given in our problem. Now I want to draw the front view, and for that first I draw the projection line. And look here that all the projection lines will be the perpendicular to the VP. Look here, we will get the top view on the HP, and in that time we will get the true shape of the top view when the angle with the HP will be 0. That means totally resting on the HP. So this is our front view and the top view, and in that time the pentagon is making the angle 0 degree with the HP and perpendicular to the VP. Now I will be making the angle 45 degree to the HP, and you look here, actually the front view is making an angle 45 degree to the HP, and this is our second step. And mind it carefully, for this action the shape of top view will be changed. Actually it will be short in size. Look at this picture and try to understand why we get the short top view. To draw any polygon, we need to know the internal angle. Look here, Here is the pentagon, hexagon or octagon, and for the pentagon n is the number of sides. For the pentagon number of sides is 5, and for hexagon n is 6, and for octagon n is 8. Now we need to calculate the internal angle for the any types of polygons. I take a pentagon, and from the center I joined by a straight line at every corner. And as for regular pentagon, this length and also the every sides is equal. And look here that as the total angle is 360, so every angle will be 360 by n. N is the number of sides. Here n is 5 for the pentagon, so this angle is 360 by n. If we assume that this angle is x, then the other angles will be also be x because of two same length. As it is a triangle, so we can write that 360 by n plus 2x is equal to 180 degree. From here we can get that 2x is equal to 180 minus 360 by n, where n is the number of sides. And you look here that 2x is the total internal angle. So this is the formula for the internal angle of any type of regular polygon. Now we will directly start to draw our problem on the drawing sheet. So first of all, we have to calculate the internal angle of pentagon. By applying the previous formula, we can calculate it easily, and the internal angle will be 108 degree. At first we will draw the ground line and give the name x and y. Then draw a perpendicular line with respect to this ground line xy. That means the angle between them will be 90 degree, and this line is the actually projection line. Then take the measure 25 millimeter for the one side of pentagon. Then put this 25 millimeter length on the projection line and dark this length because it is one side of pentagon. And at the end point of this length, draw the angle which is 108 degree. Again cut the 25 millimeter on this angular line, and of course make it dark. And from the end point draw the projection line, another projection line which is also perpendicular to the xy ground line. Taking the same length, draw an arc on this second projection line to make the intersection point between these two lines. Then join from point to point. This angle also will be 108 degree. Now taking the same length, draw another two arcs and mark the intersection point. Now just join only point to point. So this is our pentagon, and you see that every sides and every internal angle is equal. Now draw the another projection line from the rest point, and it also will be the perpendicular with the xy line. Now pointing it such that 1, 2, 3, 4, 5. So this is our top view. And for the front view, pointing it such as 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. And make it dark. So this is our front view. And this is the top view, but when it is making 0 degree angle with the HP. Now we will draw a 45 degree angle with the ground line to make an angle 45 degree with the HP. Now we just place this front view on the 45-degree angular line, and we will give the same pointing name. And after that we will also again make it dark. Now using the point of this front view, we will again draw the projection line, which is also will be the perpendicular to the XY ground line. And simultaneously we will again draw the projection line by using the point of previous true top view, and this projection line will be the parallel to the XY ground line. Carefully draw this line to make parallel with the ground line, XY line. Now mark the intersection point coming from the same point between two views. Again follow the same method. Now join from point to point. 1, 2, 2, 3, 3, 4, 4, 5, 5, 1. So this is our final top view, and this is also our final front view. So this is our final drawing. Observe thoroughly each and every point. Look at this drawing. This is the same problem, but resting condition is different. The pentagon is resting on one of its corner. This is the problem number 2, where the plane is making angle with both the plane, that means horizontal plane or vertical plane. And the problem is, draw the projection of a regular hexagon of 25 mm sides, having one side is in the HP and inclined at 60 degree to the VP, and its surface making at angle 45 degree with the HP. Now we will sort out our problem. So this is the hexagon, so the number of sides is 6, so the internal angle will be 180 minus 360 by 6, that means 120 degree. Next point is the resting condition. It is very important, and first of all you have to look out that the polygon is resting by sides or corner. So here is the resting by one of its sides. Second important thing is that we have to draw first of all the true view of the hexagon. So for the true view we need to know that the resting plane, here we see that the resting plane is on the HP. So we get true view on the HP, and when the angle with the HP will be 0. So let's start. This is our first step, where we draw the true shape of the hexagon. First of all, draw the ground line XY. Then draw the projection line which is perpendicular to the XY ground line. Take the measurement 25 mm. Then pointing in on the projection line, draw the 25 mm sides. Draw the 120 degree angle. Again take the same length, and from the end point draw another projection line which is perpendicular to the xy ground line. Taking same length, draw an arc which is cut by this projection line and join from point to point, intersection point. Again draw the projection line which is parallel to the xy ground line. To get the rest three sides of the hexagon, draw another arc taking same length, and after that join from point to point and from intersection point to intersection point. Now draw the another projection line. Give the point name of hexagon as 1, 2, 3, 4, 5, 6 for the top view, and simultaneously the same point give the point name 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash for the front view. Now make dark the front view. So this is our front view and this is our top view, and the upsides of the ground line is the vertical plane and the lower side is the horizontal plane. Second step is very important. First of all, you have to decide which inclination of the plane you have to draw at first. Is it VP or HP? In that case, you see which is the resting plane. We know that the resting plane is a horizontal plane. So first of all, we draw the inclination of the HP. That means 45 degree with the HP. If you draw the inclination with the vertical plane at first, which is not the resting plane, then it may be complicated. So first of all, we draw the inclination of resting plane. That means 45 degree with the HP. Now we'll draw the step number 2, which is inclination of 45 degree with the HP. Take any suitable point on the ground line, draw a angle with the help of protractor 45 degree. Now place the front view on this angular line. Give the same point name of the front view. Using this point from the front view, draw again the projection line which is perpendicular to the xy ground line. By using the point from the previous top view, again draw the projection line which is parallel to the xy ground line. Mark the intersection point between two projection line which is coming from the previous view for the same point. Join the point 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 1. So this is the front view and top view when it is making an angle 45 degree with the HP. Now step number 3, where we will draw the inclination of hexagon with the vertical plane which is 60 degree. Now we will draw a 60 degree angle with respect to the ground line, because if you observe that the inclination with the HP we look and draw at on the VP, and in other hands the inclination with the VP we look and draw at on the HP. So at first draw the 60 degree angle with the XY ground line. Now we have to replace the this previous top view on the 60 degree angular line. For this I will do just like a copy paste. Take the total height from the point 2 to 5. Mark the necessary point. By using this point, draw the perpendicular supporting line. Take the same distance and mark it, and you just follow the method how to copy the previous top view. This is the starting and end point of the axis point 2 and 5. Mark it and look carefully, this distance will be equal. Then give the same point name 2, 3, 4, 5, 6, 1. Then join from point to point. So this is our top view, which is making angle 60 degree with the VP. Now I'll draw again the projection line which is perpendicular to the XY ground line. Again draw the projection line from the previous front view which is parallel to the XY ground line. Again mark the intersection point between two projection line coming from previous top view and front view for the same point. Then join from point to point. So this is our final front view and our final top view. Thanks to everyone for watching this video.